Hi, and welcome back to Unit 6, Day 6, one-step mole conversion problems. This is step 2 of the practice. So we've already done step 1, where you chose the correct conversion factor based on the given and find. And now for step 2, you're using dimensional analysis to solve them. So this video is if you have questions or you're like, well, I didn't get that answer. How does that work? And you need to sort of see that. So that means you can fast forward through this for the problem that is relevant to the one you have a question to. Okay, so looking at practice problem 1, we were converting from mass to moles, and we use this as our conversion factor. So my setup will be given over 1 times my conversion factor as a fraction, and then multiply to get my answer. However, remember, one of the first steps that we need to do is before we write our given over 1, if we need to convert our units of our given, we have to do that first. So notice that the units that I have for my given are in milligrams. And remember, when you're converting from mass to moles, you have to use grams in your as your starting unit. And the reason for that is because our conversion factor is 1 mole is equal to 18.02 grams. There's grams there, not milligrams. So I'm going to have to convert this first to grams. And if you're not sure how to convert from milligrams to grams, you can go up here and look at the converting mass. So we're starting with milligrams. We want to go to grams. You have to divide the number by 1,000 to get it into grams. So I'm going to take my 258 milligrams, divide that by 1,000, and that's how I got my value in grams. Okay, so now I have my given in grams. So I'm going to take this number now and put it over 1. And then the next fraction is going to come from my conversion factor. So I want to convert this equation into a fraction. The value that goes on the top and the bottom will depend on what I want to cancel out and what I want to keep. Since I'm starting with grams, I want to cancel that out. In order for me to cancel that out, in my conversion factor fraction, grams must be in the opposite position. So it's in the top in this first fraction, and the second fraction has to be on the bottom. They need to be opposite to cancel out. So what part of my conversion factor has grams in it? My conversion factor is 1 mole is equal to 18.02 grams, so the 18.02 grams is the part that needs to go on the bottom because that has grams in it. That means what's left is my 1 mole that goes on top. Remember, these conversion factors should have 1 mole somewhere. Should be either the top or the bottom for these mole conversion problems, because all of our conversion factors have 1 mole in them, right? So that 1 mole has to be somewhere. All right, now that we've done that, we can multiply straight across. So the numerators get multiplied together, the denominators get multiplied together, and that becomes 0.258 divided by 18.02. Plug that into my calculator, and I get this value. Don't forget, I almost forget, I love this part actually. Go ahead and cancel out the units because they're of grams, since they're opposite, they cancel out. Number 2, I'm going to leave that blank because we discovered that this is a to be determined TBD problem, since we're going from volume to number of molecules, and there's no conversion factor that goes directly from volume to number of molecules. There's no arrow that connects that directly. So you can leave that part blank. For number 3, we are given 2.50 liters, so I'm going to put that in, over 1. Remember, I put over 1 just to make it into a fraction. And then the second part here, it comes from my conversion factor, so that I'm going to turn this equation into a fraction. Since I'm given my volume in liters and I want to get rid of that, that means liters must be at the bottom of that conversion factor fraction because they need to be opposite to cancel. What part of the conversion factor has liters in it? Well, my conversion factor is 1 mole is equal to 22.4 liters. So the part that has liters in it is the 22.4. So that liters, so that goes on the bottom. And then what's left of that conversion factor is the 1 mole that goes on top. Remember, the conversion factor will always have 1 mole in it for these problems because all the conversion factors have 1 mole. So then we can go ahead and cross out units. Whoosh, whoosh. And we can multiply straight across. 2.50 times 1 and 1 times 22.4. When that leaves us 2.50 divided by 22.4. When you divide that out, you get 0.112 moles. Next problem, we are given 21.6 moles, and we're trying to convert it to number of molecules. So in this case, we would start with our given 21.6 moles over 1. And just a quick note here, this is just a 1, not a 1 mole. Remember, this 1 is just to make this into a fraction. So there should never be a unit at the bottom or the denominator of that first fraction for these problems. Just a 1 to make it into a fraction. All right, so 21.6 moles over 1 are given. Now our conversion factor fraction, we get that from our conversion factor. We're given moles, we want to get rid of it, we want to cancel it out, so that means that in this conversion factor fraction, moles have to be on the bottom. We need the moles on the bottom so that the moles will cancel out. What part of this conversion factor has moles in it? Our conversion factor is 1 mole is equal to Avogadro's number. Well, it's the 1 mole that has moles in it, so I'm going to put 1 mole at the bottom so they can whoosh, whoosh, cancel out. Well, I've used this part, what's left of my conversion factor, 6.02 times 10 to the 23 molecules, Avogadro's number, so that goes on top. Then when I go to do my math, I multiply straight across, 21.6 times 6.02 times 10 to the 23. And that's what we see here, 21.6 times 6.02 times 10 to the 23. And then I'm going to, in the bottom, it's going to be 1 times 1, so that's just 1 on the bottom. So now I can go ahead and do my math by multiplying that all together, and I get 1.30 times 10 to the 25. Okay. Now, if you've got a number like 130 times 10 to the 23, that's not in scientific notation, so you would have to move the decimal over and increase the exponent by 2. If you put it into your scientific calculator, however, you do it into the calculator, it will give you this in the correct scientific notation. All right, last one, we're given 4 moles of helium, so that goes here, 4 moles over 1. Just remember that 1 is just to make it into a fraction, so no units at the bottom of that first fraction. Then the second fraction comes from our conversion factor, so we're going to figure out what goes on top and bottom. We're starting off with moles. That means we want to get rid of it. So in order for it to cancel out, it needs to be at the bottom of our second fraction. It needs to be in the denominator here so that these two can whoosh, whoosh, cancel out. So what part of the conversion factor has moles in it? It's the 1 mole. So that part, this, goes at the bottom. This, 4 grams, goes on top. And now I could do my math. 4 times 4 on the top here, and 1 times 1 on the bottom. So that's 4 times 4 over 1, which is just 16 grams. Okay? So that is how we do this. All right, so now with that being said, the next part of the problems here is part 2 practice, and these you're going to do them all together. Now, what I mean by all together, instead of showing you how to do step 1 and step 2 separately, for each problem I'm just going to do step 1 and 2 as part of one problem. We're not going to have separate videos for that. With that being said, if you want to see it done, I'm going to do these 3 examples in another video. Okay. But if you don't need to see it done, you can go ahead and skip that video and go straight into the practice and do it on your own. So basically you're solving these problems completely for yourself. So you do step 1 and you do step 2 to solve the problem completely. All right, that's it for this video.